So on this lovely day, we are going to try to find a shortcut. Instead of doing the long division, which by definition is long and tedious, we're going to see if there's a faster way, and it turns out there is. It's called synthetic division. It does have a few quirks, so you have to pay very close attention to the algorithm to make sure that we are applying it. Now, one thing to note when we are using synthetic division. The divisor is the number or letter or expression that is doing the division. The divisor must look like this. Must look like this. X plus, or technically minus, some number. So in other words, it has to be a linear term right there, no exponents attached, so this over here has to look something like this. There could be fractions, that's fine. A could be a fraction, A could be a negative, that's completely fine. So for example, notice over here, x minus 3, great, it'll work because that's a linear term, and this is whatever. This is a linear term over here, an example B, so it should work. Notice that both of these also have well, actually they're the same as below. However, the situation would not work for something like this. If I said this right here was 2x plus the 1 that we had right there. If I were dividing here, then I could not use this next method, okay? Because of that 2 in the front confuses things. All right, so let's see the magic of synthetic division. What's nice about synthetic division is that there are no letters to be had. We just leave the letters out. So here's what we do. We take a look at each coefficient, a 2, a -5, and a -3, including the constant. And we simply write that a 2, -5, -3. Give yourself a little space. Now, we're going to put a box around it, but also leave some space underneath. Okay? So leave some space inside here, because we're going to be writing some terms inside that. Okay, now here is key. Here is key. What you see here has to be oppositified and put over there. So instead of saying, and notice that we're ignoring the letters, so instead of saying -3, I'm going to place over there a +3. So I have to take the opposite of what I see. So here's our first step, is we're just going to always drop down your first term. Always drop down your first term. Next, what we have to do is multiply these two, and we're going to place the answer over there. The product goes over there. So 3 times 2 is +6. And every single time, all we do is add down. So -5 plus +6 is +1. Next, now I repeat that exact same process. This 3 is going to multiply this 1 and is going to be written over here. This 3 now multiplies this 1, and I write the answer over there. You should not use these arrows when you are actually doing it, because it'll make a mess. So the next problem, we'll do it without arrows, so it'll be a little bit easier to see. So 3 times 1 is +3, so I'm going to write my product right there. And add down. -3 plus 3 is going to give me 0. To interpret this as my answer, the 2, I place an x next to it, and I make this my constant term. There is a remainder of 0, so this is my answer. Again, where did that come from? Because I am taking a 2x squared And simply, if I oversimplify, I'm dividing by an x, 2x squared dividing by x. Notice what happens. One of those x's drop out. That one drops out, and I'm left with just an x term, which is where that came from. If my original term was a cubic, and I'm just making this up right now, and I'm still dividing by a linear term, notice what happens. One of those drop out to be a 2, and that drops out entirely. So that means my first term, just the exponent drops down by 1. So instead of originally writing a cubic, I now write a square. Originally it was square, now it becomes linear. So let's take a gander at this next example, and we're not going to use arrows. We'll just do the rhythm a little bit faster. All right, so let's go ahead and place in, side. Remember to completely ignore the letters. So the coefficient of the square term is a 1. So I have a 1, a 2, and a negative 15. Place a box around it. Remember to opposite what I see there, so I place a 1 there. Always, always, always bring the first term down. Again, this one came from there. That's the only arrow I'm going to draw. All the others I will ignore. Now we multiply this 1 on the outside times this 1 down here, and I write the answer under the 2. So I get a 1 there. Now, of course, I add down. 2 plus 1 is 3, and I begin my rhythm again. 1 times 3 is 3. Add down, negative 15 plus 3 is negative 12. And effectively, I just attach an x to that. So x plus 3 minus 12 over x minus 1. Where did that x minus 1 come from? It's my divisor here. Goes down below. This is my remainder. Goes right there with a negative. And this is the polynomial. Or writing it as remainder, x plus 3, remainder negative 12. And those are my answers. Now let's take a gander at problem number 10. Now number 10 is interesting because we are missing what looks like the quadratic term. So it goes cubic, there's no quadratic, there's a linear and a constant. So what we're going to do when we place our numbers and letters, etc. in here, or just the numbers, we have to account for the term. So notice here, this one has a coefficient of 1, so 1 goes there. There is no quadratic term, so I put a 0 there. And now I put the negative 2 and the 12 in. Don't forget that what I put outside is going to be the opposite of what I see there, so I put negative 3. Bring down the 1, multiply, and carry it over here. Bring this down, multiply, bring this down, multiply, and bring this down. Since I started with a cubic term, now I am going to have a square term there, linear term there, constant here, and this is my remainder. So the final answer is this: x squared minus 3x plus 7 minus 9 over x plus 3. And that, algebraites, is synthetic division.